Imagine lying still, silent, floating in the vastness of space. Now realize, you're moving. Not slowly, but fast. The entire Milky Way galaxy, everything you know, is speeding through space at over 600 kilometers per second. Not in orbit, not around a star, but towards something. Something huge. Something silent. Something we can't see. Astronomers call it the Great Attractor. It's not just us. Thousands of galaxies, entire clusters, are being pulled in the same direction. Like leaves caught in a current we didn't know was there. But when we point our telescopes that way, we see very little. Just a region called the zone of avoidance where our own galaxy's dust blocks the view. A cosmic blind spot. Behind it, lurking in shadow, something massive is hiding. A gravitational source so intense that it bends the motion of entire galactic superclusters. But we don't know what it is. A supercluster of galaxies? A wall of dark matter? A hidden structure beyond our understanding? We've tried to map it. We've looked in infrared, radio, X-ray. And still, no clear answers. Only this. Something is pulling us. Quietly. Constantly. Inescapably. This isn't movement like you feel in a car or a plane. This is movement on a cosmic scale. Our galaxy, the Virgo cluster, even the entire Laniakea supercluster. All part of this quiet drift toward what? Some scientists believe it's a region called the Shapley supercluster, even farther away than the Great Attractor. Maybe what we thought was the destination was just the first clue. Maybe we're not falling toward a point, but being pulled along a gravitational river, into something vaster than we've ever imagined. Maybe, just maybe, we'll never know, because in the end we're not at the center of the universe. We're passengers on a ship in a current flowing toward a destination we cannot see and do not understand. And that's the feeling the Great Attractor leaves you with. The soft, unsettling truth that even the galaxy isn't standing still. That space itself has tides, and something enormous is waiting, just out of sight. August 15, 1977. A quiet night in Ohio. The Big Ear radio telescope scans the sky, searching for whispers, signals from distant stars. Random static. Background hum. Just another night of cosmic listening. And then, it happens. A burst. A sudden loud, clear signal. Exactly the kind SETI, the search for extraterrestrial intelligence, had been waiting for. 72 seconds long. Coming from deep space. Narrow band. Precise. Focused. Nothing nature normally produces. Astronomer Jerry Emmons circles it on the printout and writes just one word in the margin. Wow. It becomes known simply as the WOW signal, and it remains to this day one of the most tantalizing, unexplained events in the history of space listening. What was it? Not a star. Not a pulsar. Not a planet. Not any known satellite or earthly interference. It came from the direction of the constellation Sagittarius, near a group of stars called Chi Sagittarii, around 120 light-years away. But here's the strange part. It never happened again. We pointed our telescopes back to that spot again and again. We listened. We waited. Silence. No follow-up. No repeat. Just that one blip. One voice. 172-second moment of something. Could it have been a greeting? A beacon from a distant intelligence timed perfectly, missed forever? Or was it a mistake? A one-time glitch? A strange natural phenomenon we simply don't understand yet? We've tried to explain it. Comets, reflections, secret military tests. But none of the theories quite hold up. They explain part of the signal but not all of it. And that's what makes it so haunting. It was clear. It was narrow. It looked artificial. And then it was gone. If it was an alien civilization, they may not know we heard them. Or they may have moved on. Or died out. Or maybe it was just their version of turning on a light. For a second. Long enough to say, we're here. And if that's true, then you are alive in a universe where we briefly, so briefly, heard a voice not our own. No. Just the silence again. Endless, empty quiet. With that one strange echo still unexplained. Still hanging in the dark. There's a quiet current in space. You can't see it. You can't hear it. But something is pulling. Not just stars. Not just galaxies. But entire galactic clusters. Sliding in one direction across the fabric of space-time. This is the mystery known as dark flow. In 2008, scientists noticed something strange. They studied galaxy clusters billions of light-years away, using the cosmic microwave background, the afterglow of the Big Bang, as a kind of backdrop. And they saw it. A slow, steady motion. Massive clusters drifting in the same direction, toward the edge of the observable universe. It wasn't random. It wasn't subtle. It was as if some immense force far beyond our visible universe was reaching across the void and pulling. The speed? Up to 1,000 kilometers per second. A whisper of motion on a cosmic scale. But here's the eerie part. We don't know what they're moving toward, or why. They're heading into a region we can't see, beyond the cosmic horizon, past the limits of observation. A place no telescope can ever reach. It's like watching ships disappear over a foggy ocean, pulled by a tide we cannot trace. Some theorists suggest massive structures lie beyond our universe, regions of extreme gravity or even other universes, tugging at us through some unknown connection. Others propose the presence of pre-Big Bang remnants, cosmic scars from a reality that existed before time began. And some, they wonder if this motion is proof that our universe is part of something far larger. Not infinite space, but a multiversal ocean, and we are a small ripple caught in a greater wave. The name dark flow says it all. Dark because we can't see what's causing it. Flow because it feels like a current, slow and steady, guiding galaxies toward something ancient and unknown. And yet, recent studies have questioned it. Some say the motion may be statistical noise. Others still see the signal, subtle but persistent. So we're left with this, an open question. A cosmic breeze we may never fully understand. A motion toward the unknowable edge. And somewhere deep in that darkness, something may be watching us drift closer. Not fast, not loud, just away. What causes these mysterious fleeting bursts of cosmic radio waves? It starts with silence. Then suddenly, flash. Not of light, but of radio. An intense burst of energy from deep space. Gone in milliseconds. But powerful, releasing more energy in a blink than the sun does in days. These are called fast radio bursts, FRBs. And we don't know what they are. The first one was discovered in 2007, buried in telescope data. So brief, so strange, it was almost dismissed as an error. But more came. Dozens, then hundreds. Now we know they're real. They come from billions of light-years away. Some repeat, others don't. Some are one-off pulses from the void, like something screaming once then going quiet forever. Others stutter and speak again and again in irregular, cryptic patterns. What's making them? Are they the death screams of collapsing stars? The aftermath of neutron star collisions? The magnetic snap of twisted cosmic fields? Or are they messages? That's where the mystery turns eerie. Because some FRBs are incredibly precise. So fast, so sharp, so clean, they feel intentional. As if something wanted to be noticed. Scientists have even joked, nervously, that it's aliens. And while no one claims that seriously, no one can fully rule it out either. Because FRBs behave in ways we can't predict. And some have been traced to galaxies that shouldn't be producing signals like this. Small, dim galaxies, hiding something bright and loud. It's like hearing a knock at the door of a house you thought was abandoned. And here's the catch. We can't catch them in real time. By the time you notice an FRB, it's already gone. You can't aim your telescope fast enough. They're shadows. Echoes. Blinking lights from behind a curtain. And what if they're not random? What if they're a pattern we haven't cracked yet? A warning. A greeting. A map. A code. Or maybe just cosmic weather that we don't yet understand. But there's something deeply unsettling about brief signals from nowhere, coming at us through billions of years of space and time. You hear them. You write them down. And then the universe goes quiet again, leaving you with nothing but the question, who or what is out there, whispering once and never again. Why does this distant star flicker unpredictably? Most stars are steady, reliable. They pulse, shift, and dim in predictable ways, like cosmic clocks. But one star broke the pattern. In 2015, astronomers noticed something strange about a distant star named KIC 8462852, later nicknamed Tabby's star. It wasn't pulsing like usual. It was dimming. Not once, not slightly, but deeply and irregularly. Sometimes by 5%. Sometimes by 15%. At one point, by over 20%. That might not sound like much, but it's enormous. Even a giant planet like Jupiter would only dim a star by about 1% when passing in front of it. This star, over 1,400 light-years away, was acting like something massive and strangely shaped was blocking its light. And no one could explain it. They ruled out planets. They ruled out star spots. They ruled out binary companions or instrument error. So the theories grew more exotic. Dust clouds. Maybe. But the dimming didn't behave like dust. Swarming comets? Possible, but no known comet behavior matches what we saw. And then came the idea that caught fire. What if it's an alien megastructure? A Dyson swarm, a hypothetical structure built by an advanced civilization to capture a star's energy. Sounds like science fiction, but it fits. An uneven, shifting structure orbiting the star could create exactly the bizarre dimming pattern we observed. Of course, astronomers are cautious. Extraordinary claims require extraordinary evidence. And to this day, no signal, no data confirms anything artificial. But the star hasn't stopped flickering. Over the years, it's continued its strange, uneven fade. And each time it dims, the mystery deepens. If it's natural, it's a kind of nature we've never seen before. If it's artificial, it's the closest we've ever come to seeing someone else's blueprint. Either way, Tabby's star remains a cosmic question mark. A light in the sky that doesn't just shine, it blinks, as if something, or someone, is getting in the way. And until we understand it, we'll keep watching. Quietly, patiently. Because in a universe this vast, even one flickering star might mean we're not alone. We like to think we understand the universe. We build telescopes, smash particles, write down equations. But even with all that, there's a glaring hole in the story. Where is the missing matter? Not dark matter. Not dark energy. We're talking about ordinary matter. Protons, neutrons, atoms. The stuff that makes stars, planets, people. Baryons. And about a third of them are gone. Here's the unsettling part. We can calculate how many baryons should exist based on the physics of the early universe. How much hydrogen and helium should have formed, how galaxies should have evolved. But when we look out into space and count all the stars, galaxies, gas clouds, black holes, we come up short. A huge chunk of normal matter is just missing. So where is it? Some believe it's hiding in the intergalactic medium, thin, hot threads of gas stretched between galaxies like a cosmic web. Not bright, not dense, just enough to slip through our instruments. A ghost structure gently humming in X-rays we can barely detect. Others think these baryons may be floating freely in warm, hot intergalactic filaments, invisible to traditional telescopes. Not gone, just dispersed like fog in the dark. But the truth is, for decades we simply couldn't find them. The math said they were there. The universe acted like they were there. But when we looked, there was nothing. And that opens the door to even stranger possibilities. What if some of that ordinary matter has transformed, shifted into exotic states we can't yet detect? Or what if it's a simulation glitch? The system only renders matter where needed, and the rest exists as unrendered placeholders unseen until observed. In that case, the missing baryons aren't really gone. They were never meant to be found. They exist in code but not in experience. Whatever the answer, the feeling lingers. The universe is hiding something. Not in some distant galaxy, but in the gaps between everything else. You look up thinking the cosmos is made of stars and light. But really, it's mostly absence. The missing. The invisible. The not quite there. And maybe that's what makes space so vast. Not what it contains, but what it refuses to show. Why does this massive cosmic void remain mysteriously empty? Space is big, but it's not empty. Galaxies stretch across the sky like grains of sand on an endless shore. Everywhere you look, there's something. Except here. There's a patch of space so vast, so barren that astronomers call it the Boötes void. It spans 330 million light-years across. That's not a gap between galaxies. It's a cosmic desert. A region so empty, so still, it seems to defy the laws of cosmic structure. When it was first discovered in the 1980s, scientists expected to find galaxies hiding inside. Maybe they were faint. Maybe the instruments missed them. But the more they looked, the more nothing they found. In a universe where galaxies form clusters, filaments, and webs, the Boötes void sits like a hole in the fabric of reality. Contains a few dozen galaxies, but for its size it should contain thousands. Why is it so empty? Some think it's just a statistical fluke, a rare region where gravity didn't pull matter together during the universe's formation. Others suggest it could be the result of galactic collisions long ago. Massive structures clearing out space like ripples in a pond. And then, there are stranger ideas. What if it's not empty, but hidden? What if something blocks the light? Something we can't detect? Dark matter? A cloaking phenomenon? A break in our understanding of cosmology? Or what if it's evidence of cosmic editing? A patch of reality erased, altered, or left unfinished. Like a forgotten corner in a simulation's code. Some even wonder if the Boötes void is the edge of something bigger. A sign that our universe is one of many. And this is where the seams begin to show. But maybe the scariest explanation is the simplest one. It's just empty. In the middle of everything. A silence no star has ever broken. A place where the universe simply didn't happen. And yet, light from those few lonely galaxies still reaches us. Quiet reminders that even in the darkest places, something endures. So if you ever feel small, remember, there's a place in the sky so vast and so forgotten that our entire galaxy could vanish inside it, and no one would notice. How could the universe expand faster than light itself? The Big Bang wasn't just an explosion. It was the birth of everything. Space, time, energy, all erupting from a single point. But that's not the whole story. Not even close. Because right after that first instant, before atoms, before light, before matter itself, something happened that defies all logic. The universe grew faster than the speed of light. Not a little faster. Not twice as fast. But expanding by a factor of 10 in less than a fraction of a second. This is the theory of cosmic inflation. In the tiniest sliver of time imaginable, a trillionth of a trillionth of a trillionth of a second, the universe ballooned from smaller than a proton to larger than a galaxy. Space itself didn't just stretch. It exploded outward. No particles. No stars. No direction. Just raw space expanding faster than light could ever travel. And that's the paradox. According to Einstein, nothing can move faster than light. But during inflation, space itself expanded. And space isn't bound by light speed. So what caused it? We don't know. Some say it was triggered by a field. something called the inflaton, a hypothetical energy force that briefly drove this expansion before decaying and giving rise to all known particles. Others say it may have been a quantum fluctuation, a ripple in nothingness that ignited everything. But why would the universe do this? Why expand faster than anything should? Why cheat the rules of physics right at the beginning? Because without inflation, the universe doesn't make sense. The sky is too smooth. Distant regions of the cosmos are too similar. There's not enough time or temperature or distance to explain how the universe became so uniform. Inflation solves these problems. It explains the smoothness. It predicts the structure. It gives us a reason why the universe looks the way it does. But it also opens up something else. The multiverse. If inflation happened once, it might happen again. Forever. Each bubble of space growing, budding, and creating new universes. Each with its own laws, particles, physics. And we might just be one spark in an eternal wildfire of expanding reality. Or, if this is a simulation, inflation might be the boot-up sequence. The moment the program went live. Everything expanding instantly, rendering the background before the players arrive. Whatever the answer, it's deeply unsettling. Because at the core of it all, beneath galaxies, beneath time, lies a moment so fast, so strange, so explosive, we may never fully understand it. A moment where everything began, by breaking every rule we thought reality had. In 2017, astronomers spotted something strange streaking through our solar system. It wasn't a comet. It wasn't an asteroid. It didn't behave like anything we'd seen before. They named it Oumuamua, a Hawaiian word meaning scout or messenger from afar. Because that's what it was. The first known object to enter our solar system from another star system. It came from the deep dark. No orbit, no return trip. Just a one-way journey through our celestial neighborhood. And immediately, it defied explanation. It was long and thin like a needle or a pancake, not like typical space rocks. It spun oddly. And most curious of all, it accelerated as it left the sun. Not because of gravity. Not because of ice jets like comets do. But something else. Something unexplained. Some scientists said it could be hydrogen ice, evaporating without leaving a visible trail. Others said it was a fragment of a shredded planet or an exotic shard of cosmic debris. And then came another possibility. What if it wasn't natural at all? What if Oumuamua was a probe? A light sail? A relic of alien technology, abandoned, drifting, or sent? Harvard astronomer Avi Loeb famously suggested it could be artificial. Not as a wild claim, but as a serious scientific hypothesis. If we saw something this weird from Earth, he argued, we'd at least consider the possibility of design. And yet, as fast as it appeared, it was gone. Too small, too fast, too distant to follow. No way to chase it. No way to catch it. Only its fading trail, its brief glimmer through our telescopes. We may never know what it was. A strange rock? A natural phenomenon we don't yet understand? Or a visitor gliding silently by unnoticed, until it was too late? But here's the thought that lingers. If we missed this one, how many others have passed through unseen? How many messengers brushed the edge of our world and slipped back into the dark? Maybe Oumuamua wasn't the first. Maybe it won't be the last. Maybe the stars are filled with drifting artifacts, and this was just the first one to whisper, "You're not alone." Do mysterious threads stretch silently across space and time? Imagine space-time like a sheet. Smooth, unbroken, flowing quietly across the cosmos. Now imagine a scar, a wrinkle, a tear, a line that isn't supposed to be there. That's a cosmic string, not a string like yarn or wire. These are theoretical one-dimensional defects, infinitely thin but infinitely long, like seams left over from the universe's birth, stretching across space, sharp, dense, and incredibly strange. Some scientists believe these strings could have formed just after the Big Bang, cracks in the cooling structure of spacetime itself. Not made of matter but of pure energy compressed into a line. A single strand could weigh more than an entire mountain per inch. They'd be invisible, but their gravity? Unforgettable. If a cosmic string passed through space, it could bend light like a lens, distort galaxies, or even cause ripples, gravitational waves, as it vibrates. A leftover scar. From the moment time began. No one's seen one yet. But we've seen hints. Odd distortions in starlight, strange gravitational lensing events, even unexplained cosmic microwave background patterns. Not proof, but echoes. Ripples that something may be there. And here's where it gets eerie. Some theories suggest cosmic strings might be looped, forming tight knots that vibrate and decay over time. Others say they're infinitely long, stretching through the cosmos like threads from another dimension. Or worse, tethers between universes. Cosmic strings might not just be defects. They might be bridges, portals between different realities, or boundaries where universes touch. Some even think these strings could be artificial, engineered by advanced civilizations to manipulate gravity, space, or time itself. In simulation theory, cosmic strings could be rendering seams. The glitch lines, the joins in the fabric, never meant to be seen but there, if you look just right. And maybe that's what they are. Clues. Leftovers. Cracks. Proof that the universe isn't as smooth as it looks. That something deeper lies beneath. So as we stare into the stars, measuring light, tracking orbits, mapping the sky, we may one day trip over one of these scars. Not a star. Not a planet. Not a galaxy. A line. A thread. A sign that the universe was stitched together. And it's beginning to show. Why is there a chilly void in the cosmic microwave background radiation? After the Big Bang, the universe was filled with light. Not blinding, not visible, but a soft, uniform glow called the cosmic microwave background. It's the baby picture of the cosmos, still echoing across the sky. It should be smooth, predictable, warm in cosmic terms, but hidden in that gentle hum is a place that isn't. A cold spot. A massive, unusually empty region of the universe. Cooler than the rest of the cosmic backdrop. It's located in the constellation Eridanus, and it's huge. Stretching across 1.8 billion light-years. This spot is colder by several hundred microkelvins than the surrounding space. Tiny difference. Big implications. Why is it there? And why is it so cold? At first, scientists thought it was a supervoid. A large area with fewer galaxies than normal. Less matter means less energy. Maybe that explained the dimness, the chill. But even that doesn't add up. This spot is too cold. Too large. Too strange. Some propose it's just a statistical fluke, an unlikely dip that happened by chance. But others aren't so sure. A few physicists have dared to ask, could this be a bruise from another universe? A scar from a collision, when our universe bumped into another. Early in its inflationary growth? If the multiverse is real, then our universe might not be alone. And this cold spot could be contact. A ripple. A memory. A crack in the cosmic shell. And in the simulation view, it might be a rendering anomaly, an oversight, a region of low-resolution spacetime. Like a glitch at the edge of a video game map. Not cold by physics, but by design. We can't test it. We can't reach it. We can only see it and wonder. What could carve a hole in the heat of creation? What could chill the fire left over from the birth of time? Maybe it's nothing. Or maybe it's evidence of something beyond everything. And when you look up at the sky, know that somewhere out there, there's a place where the universe still whispers cold. Could these regular signals hide deeper, unknown secrets? Far out in deep space, long after a star dies, something strange remains, or collapsed, heavy beyond comprehension, spins, Fast. Violently fast. And as it spins, it sends out beams of radiation. Tight, focused, pulsing. Pulsars. We first detected them in 1967. The signals were so regular, so precise. They were labeled Algernon. Little green men. We didn't know what else could be so consistent. But they weren't aliens, at least not as far as we can prove. They were neutron stars. Stars that collapsed into balls the size of cities, spinning hundreds of times per second. Like cosmic lighthouses, sweeping their beams across the cosmos. They flash, flash, flash. With atomic clock precision. But here's the unsettling part. Some of them don't behave like they should. They glitch. Pause. Change rhythm. Some emit giant pulses, random and unexplained. Some suddenly go quiet, dark, then return with no warning. And a few? They don't repeat. One signal. One flash. Then nothing. What caused it? No known pattern. No obvious source. Just a pulse in the dark, then silence. Some pulsars even move. Kicked across the galaxy at speeds we can't explain. As if they were launched by something. Or towards something. And then there are the millisecond pulsars. Spinning up to 700 times per second. That's faster than a kitchen blender. Imagine a dead star heavier than the sun, spinning hundreds of times per second forever. Why so fast? What's feeding them? Why don't they slow down? We don't fully know. Some believe they're feeding off a companion star. Others think they're being spun up by unseen forces, or by artificial means. Because if you were an advanced civilization, and you wanted to send out a beacon, one that could last millions of years, immune to decay, you might build a pulsar, or modify one, or hide your messages inside one. Some scientists are even studying pulsars as natural GPS systems, stable enough to navigate deep space with them. Like ancient cosmic satellites, left running for anyone smart enough to use them. But maybe they're more than that. Maybe they're not just the echoes of dead stars. Maybe they're something else. Clocks, warnings, codes, or calls we haven't yet answered. So next time you look at a star, imagine one that has died, and is still spinning, still pulsing, still sending out its quiet rhythm into the dark, waiting. Is there a massive unseen planet lurking silently at the edge of our solar system? Beyond Neptune, past the icy edge of Pluto, lies the dark. An expanse of space so empty, so cold, you'd think there's nothing left to find. But something's out there. Something big. Something pulling. Astronomers have noticed strange behavior in the orbits of distant icy objects. Kuiper belt bodies far beyond the known planets. They're tilted, clustered, moving in ways that don't quite make sense. It's as if something massive is tugging on them. From the dark. They've done the math. They've ruled out randomness. They've ruled out known planets. And what's left is Planet 9. An unseen world. Maybe 10 times the mass of Earth. Maybe 20 times farther from the Sun than Neptune. Too far to see with our best telescopes. Too slow to betray its motion quickly. But big enough to gently rearrange the solar system's outer edge. If it's real, it's not a frozen rock like Pluto. It could be a mini gas giant, a lonely wanderer orbiting in the blackness, taking 10,000 to 20,000 years to complete a single loop around the Sun. And here's the mystery. Why haven't we seen it? We've scanned the skies. We've looked with infrared sensors and deep sky surveys. But Planet 9 hides, if it exists, along a path that remains just out of reach. A needle in the cosmic haystack. Some say it's not a planet at all. Maybe a primordial black hole the size of a grapefruit, but with the mass of a planet, dark and impossible to see. Others suggest it's a captured rogue planet, an object flung from another solar system now trapped in ours. Or maybe it's not there. Maybe the orbits are off because our math is incomplete. Maybe the anomaly is in us, in our models, not the sky. But the idea won't go away. Because space doesn't lie. The outer solar system feels like something's out there. A shadow moving in the deep. A ghost planet. Or maybe a reminder that the solar system isn't finished. That discovery didn't end with Neptune. That even now in the 21st century, there are still worlds waiting to be found. And if Planet 9 is real, then one day someone will point a telescope at the right patch of sky and find it staring back. Black holes are terrifying. They don't just pull in matter. They swallow space, time, even information. Cross the event horizon and there's no coming back. But what if black holes don't end things? What if they begin something else? This is the black hole-white hole paradox. An idea whispered at the edge of physics. You know, black holes. Massive, collapsed stars with gravity so strong not even light escapes. But on the other side of theory, almost like a mirror, are white holes. Where black holes devour, white holes expel. Where nothing can escape a black hole. Nothing can enter a white hole. It's a theoretical object, never seen, never confirmed. But some equations suggest black holes and white holes are connected. Two ends of the same tunnel. A wormhole. A bridge between realities. A passage from our universe to somewhere else. Maybe when something falls into a black hole, it doesn't vanish. It's ejected through a white hole, maybe in another part of our universe. Or maybe in a completely different one. That's where the paradox gets wild. Because black holes erase information. But quantum physics says information can't be destroyed. So where does it go? Maybe the black hole encodes it. Maybe it leaks out slowly via Hawking radiation. Or maybe it's passed through to a new universe. One born inside the black hole itself. In this view, every black hole is a cosmic seed. Every collapse is a creation. And what about white holes? If they exist, they might only appear in the earliest moments of a new universe. A big bang on the other side of a black hole's death. A violent eruption of matter, time, and space. Our universe's beginning. Could our Big Bang have been a white hole explosion? From the collapse of another universe? Are we living inside the aftermath of someone else's black hole? It's possible. And deeply humbling. Because it means our universe may not be the only one. It might be one of many, blooming quietly from the deaths of others. Universes giving birth to universes, in a grand cycle of collapse and rebirth. Or, in simulation terms, black holes might be exit points. Shutdown commands. When something leaves the rendered world, it doesn't die. It simply logs out. White holes. Maybe they're boot-up points. Simulations spinning into being from stored data, starting their own story, unaware of what came before. Either way, the paradox stands. If black holes destroy, then what creates? And if something leaks out of them, where is it going? Maybe someday we'll find out. Or maybe we already have. By living on the other side. If intelligent life is common, why is the universe so quiet? Look up. There are more stars in the universe than grains of sand on every beach on Earth. Many of those stars have planets. Some of those planets may have oceans. And time, billions of years of it, for life to emerge, evolve, and look up just like we do. So the question is simple. Where is everyone? That's the Fermi paradox. A collision between the probability that intelligent life should exist and the absolute silence we hear when we listen. We've scanned the skies. We've watched for ships. We've listened for signals. Nothing. Not a whisper. Not a flicker. Just the long, dark quiet. So where are they? Here are some of the possibilities, and each one is unsettling in its own way. They're out there, but hiding. Advanced civilizations may use technology that's undetectable to us. Or maybe they deliberately stay silent. The dark forest theory. Everyone hides because shouting into the void is dangerous. They were here, but they're gone. Maybe intelligent life does emerge, but it always destroys itself. Or environmental collapse. AI. Civilizations rise, burn bright, then vanish, leaving no trace. We're early. What if we're among the first? A lonely outpost in a young universe. The others are coming, but haven't had time yet. They're already here, but we don't recognize them. Maybe alien life isn't carbon-based. Maybe it's AI or planetary scale or quantum level. Maybe we're surrounded, and too primitive to know it. We're in a simulation. This is a constructed reality. Maybe it was designed for us, and no other players are loaded in. Just enough stars to keep us curious. But no one home. Or maybe we really are alone. Not just in the galaxy, but in the entire universe. And that's the most haunting idea of all. Because if it's true, if we are the only intelligent species to ever look at the stars, then we carry a responsibility beyond imagination. To survive. To explore. To become what we hope to find. The silence isn't proof of absence. It's a mirror. And maybe the real question isn't where are they? Maybe it's, what will we become, now that we know no one is coming? What invisible forces send powerful rays hurtling through space toward us? You can't see them. You can't feel them. But they're hitting you. Right now. Cosmic rays. Tiny particles, mostly protons, slamming into Earth's atmosphere at near light speed. Not one or two, but hundreds per second per square meter. Passing through your body. Through buildings. Through everything. But where do they come from? Some we understand. The sun throws out solar rays, energetic but manageable. Supernovae, exploding stars, also contribute. But others? We have no idea. Some cosmic rays are so powerful they defy explanation. Millions of times more energetic than anything our best particle accelerators can create. So powerful, in fact, that they might not even survive the trip through intergalactic space. And yet they get here. From what? Magnetars? Quasars? Black hole jets? Something beyond our understanding? They don't travel in straight lines. Magnetic fields bend their paths. So by the time they arrive, we don't know where they came from. Just that they're here. Moving fast. Invisible. Unstoppable. Some scientists think they may come from dark matter interactions. Others wonder if they're linked to decaying relics from the Big Bang. And then there's the most haunting possibility. They're messages. Or artifacts. Or leakage. From another place, another dimension, or another intelligence. In 1962, a single cosmic ray was detected carrying so much energy, it was dubbed the "Oh my God" particle. It hit our atmosphere with the force of a fast-pitched baseball, and it was just one proton. But that's not natural. Or at least not easily natural. So what if these ultra-high-energy cosmic rays are signals? Or byproducts of something not yet visible? Not just energy, but intent? And in simulation theory, cosmic rays might be corrections, low-level pings, data injections, signals to keep the simulated physics in check, coming from outside the rendered space. Or maybe they're leaks. From other layers. Other universes bleeding in. They move in silence. They flash in brief moments. They arrive without warning and leave no trace except for what they hit. The universe doesn't shout. Sometimes it taps. Hard. And we're still listening. What exactly fuels these incredibly luminous cosmic beacons? Far beyond our galaxy, at the edge of time and space, something is glowing with more power than entire galaxies combined. A pinpoint of light, more distant than most telescopes can reach. But so bright, it outshines billions of stars. This is a quasar. Short for quasi-stellar radio source. Quasars were first discovered in the 1960s. At first, astronomers thought they were stars. But their light didn't make sense. It was too bright, too energetic, and coming from too far away. What they were really seeing. The hearts of young galaxies, where supermassive black holes are devouring matter at incredible speeds. And in that violent feast, as gas and dust spiral in, friction creates unimaginable energy. Jets of radiation shoot out for millions of light years, screaming across the cosmos. A black hole surrounded by a glowing halo of death. But even that doesn't fully explain it. Some quasars shine with energy equivalent to 1,000 Milky Ways. Their light has traveled for billions of years, showing us the universe when it was young, less than a tenth its current age. So here's the mystery. Why were quasars so common in the early universe? And why are they almost gone now? Have they gone dormant? Have they burned out? Or have they transformed into something else entirely? And stranger still, we've seen quasars change brightness rapidly, something that should take centuries happening in just a few years. Some scientists think we might be misunderstanding them entirely, that maybe they're not just black holes, but something we haven't classified yet, a cosmic phase we barely caught before it vanished. Others ask if quasars might be signals, not natural objects but engineered beacons, power sources for advanced civilizations, engines, warnings, and in a simulated universe? Maybe quasars are the rendering engines, regions where processing power is maxed out, where the simulation pumps out maximum energy to handle complexity we can't comprehend. They don't blink. They roar. From across the void, they shout that the universe was once hot, young, wild, and lit by monsters we can barely understand. Quasars are more than lights. They are messages from a universe that was still on fire. Are vast numbers of stars silently hidden behind thick cosmic veils? When you look into the night sky, you see stars, billions of them, but not all of them. Some are missing, not gone, just hidden, behind thick cold walls of dust, lost in the shadows of the cosmos. These are cosmic dust clouds, massive dark structures drifting through galaxies, made of fine particles of carbon, silicates, and ices. Too thin to see up close, too vast to see past. They don't glow. They block light from stars, entire systems, even galaxies, smothered, dimmed, erased. There are places in space that look empty, but they're not. They're cloaked. These clouds stretch across light years, and in their depths we don't know what's there. Maybe thousands, millions, of stars we've never seen. Maybe planets. Maybe black holes. Maybe something else. And this leads to an unsettling question. What if a huge part of the universe is hidden? Not because it's far away, but because it's covered? There are entire regions, like the zone of avoidance, where our own galaxy's dust blocks our view of what's behind it. And when we finally peek through with infrared or radio telescopes, we sometimes find entire galaxies we never knew were there. Whole structures, missing pieces of the cosmic puzzle. And what if some of the weird signals we get, the fast radio bursts, the missing baryons, the faint flickers, aren't coming from nowhere, but from behind the curtain? Maybe the dust isn't just hiding stars. Maybe it's hiding stories. Some scientists wonder, could ancient civilizations be hiding there too? Their stars cloaked not just by nature, but by design? The ultimate camouflage. Stay behind the veil. Stay invisible. Watch. Or maybe not. Maybe it's just nature. Chaotic. And even obscured. But still, there's something eerie about dark patches in space. Not empty. Not silent. Just unknown. Like looking into fog and sensing movement. And in a simulated world, maybe dust clouds are rendering shortcuts. Areas the system hasn't drawn in detail. Low-res zones that don't matter until someone looks. Or maybe they're partitions. Boundaries between levels. Between the known and the not yet allowed. So next time you stare at a blank patch of sky, ask yourself, what's really out there? And why aren't we allowed to see it? What invisible structures bind galaxies together like neurons in a brain? Zoom all the way out. Farther than stars. Farther than galaxies. Farther than clusters of galaxies. What you see doesn't look random. It looks structured. Like something was drawn with a careful hand. This is the cosmic web, the vast interconnected scaffolding of the universe. Not scattered galaxies, not chaos, but filaments stretching across billions of light years, connecting everything. Galaxies aren't alone. They live along threads of dark matter and gas, clustered at intersections like cosmic cities at the junction of intergalactic highways. And between those threads, voids, giant, empty regions where matter is scarce and silence reigns. It's stunning. It's mathematical. It's beautiful. But here's the mystery. How did the universe end up looking like this? And what does it mean? The cosmic web formed through gravity and time. Tiny fluctuations in the early universe magnified over billions of years, drawing matter together into patterns. But those patterns are familiar. They look like neural networks, like synapses, like the structure of the human brain. That's not a metaphor. The distribution of galaxies and the mapping of neurons are mathematically similar. Which raises a strange question. Is the universe thinking? Or are we seeing a shape we're wired to recognize? Some suggest the universe is a kind of mind, a vast informational system evolving complexity at scale. Or maybe our brains evolved in the shape of the universe because that's the system we emerged from. And what holds it all together? Not just gravity, but dark matter, the unseen substance that makes up most of the universe's mass. We can't see it, but we see its influence pulling galaxies into line, guiding the shape of the web. In simulation theory, this web might be data infrastructure, the scaffolding behind the render, a visual echo of the system's architecture. What if the universe looks like a brain? Because it's running one? Or maybe it's just coincidence, patterns made from physics and time. No mind, no message, just form. But the next time you look at a map of the galaxies, and you see the delicate threads connecting everything, remember, the universe doesn't just contain structure. It is structure, vast, hidden, and quietly alive in the dark. What triggers these most powerful and mysterious cosmic flashes? No warning, no build-up, just a flash. In a fraction of a second, more energy is released than our sun will produce in its entire 10 billion-year life. Gamma-ray bursts, turbines, the most violent high-energy explosions we've ever seen. They come from deep space, distant galaxies, billions of light-years away. They arrive like sirens, blinding detectors, flooding instruments, then vanishing before we can even point our telescopes. Some last a few seconds, others less than a blink. What could cause such power? The leading theories? A massive star collapsing into a black hole. Two neutron stars colliding, tearing space apart. Or even primordial black holes evaporating in bursts of fury. Whatever the cause, these events are cosmic-scale violence. Space itself rupturing under pressure. But here's what makes it unsettling. We don't know exactly where they'll happen. We don't know when. And if one went off close enough to Earth, it could erase us. Not with sound or fire, but with radiation. A close GRB could strip away our atmosphere, ignite global fires, or trigger a mass extinction. Some scientists believe one may have already hit Earth millions of years ago, possibly linked to the Ordovician extinction event. But these aren't just threats. They're messages, bursts that reach across time. Flashes from dead stars, or something stranger, telling us a story we don't understand yet. Some GRBs are so distant, they happened before Earth even existed. We're catching the death screams of stars older than the Milky Way. Or the echoes of events we can't explain. Some GRBs show weird structure. Multiple peaks, strange time delays, unexpected afterglows. Are we seeing physics at the limit? Or evidence of something weirder? In simulation theory, GRBs might be system resets. Points where rules were rewritten. Massive debug events, rewriting vast areas of code in a flash. Or maybe they're not destructive at all. Maybe they're beacons. The kind you send out when you're trying to get noticed across a multiverse. Loud, bright, impossible to ignore. And here we are, watching them from the safety of distance. Or maybe just waiting our turn. So the next time you hear gamma ray burst, don't just think explosion. Think warning. Think story. Think signal. There's something somewhere. Just lit a match in the dark. What untold cosmic catastrophes are these subtle waves revealing? Imagine space as a vast, invisible fabric. Now imagine that fabric ripples. Not like sound. Not like light. But deeper. More fundamental. These are gravitational waves, distortions in space-time itself. And for most of human history, we never knew they existed. Then in 2015 we heard one. A tiny wobble. Smaller than an atom. Caught by two enormous laser detectors on opposite ends of the Earth. It came from 1.3 billion light-years away. Two black holes had collided. Their final spiral unleashed a wave, like the ring of a distant bell. A soundless echo from the past, still moving through the cosmos. It was the first time we'd ever heard space move. And since then we've heard more. Mergers of black holes. Neutron stars slamming into each other. Collisions so violent they shook the very fabric of the universe. But here's the haunting part. Gravitational waves don't fade like sound. They don't scatter like light. They pass through everything. Stone, stars, flesh. They ripple through you, undetectable, unstoppable, ancient. What else could they reveal? Some think they'll let us listen to the beginning of time, the Big Bang's leftover waves, still trembling in the dark. Others hope they'll uncover cosmic strings, wormholes, or even parallel universes, brushing against ours with just enough force to stir the fabric. In simulation terms, gravitational waves might be data updates. Ripples not in space but in the system. The code shifting slightly as major events happen. A record. A glitch. A whisper from deep inside the machine. And maybe one day they'll uncover something we never expected. A wave from a source with no light. No shape. No explanation. A collision. With what? We don't know. We're just learning to listen. So as you lie still tonight, remember. Somewhere in space, stars are colliding. Black holes are merging. And the universe is whispering across the void. Pi waves. Passing through everything you've ever known. Why does this gentle, mysterious glow linger near the horizon? Just before dawn, or just after dusk. If the sky is dark enough, clear enough, you might see it. A faint, cone-shaped glow rising from the horizon. Too soft to be moonlight. Too large to be a star. It's called the Zodiacal light. An ancient mystery. A gentle, ghostly shimmer that stretches through the constellations of the zodiac. Not many people see it. Fewer still know what it is. For centuries it was unexplained. A strange pillar of light hovering silently in the sky. Now we know it's real. But it's still strange. It comes from dust. Tiny particles, leftovers from comets and asteroids, orbiting the sun. Floating in a vast flat cloud across the inner solar system. This dust scatters sunlight, creating the dim glow. But here's where it gets weird. There's too much dust. More than current comet activity should produce. Where is it coming from? Why hasn't it settled? Why does it linger century after century? Some scientists think the dust is ancient, a fossil from the solar system's formation. Others suspect a recent collision far beyond Pluto. Maybe even a hidden asteroid belt still undiscovered. And then there's the eerie part. The dust cloud is denser near Earth's orbit. Almost like something is drawing it closer. Could this be the sign of an unseen planet? A gravitational trap? Or something artificial? In 2021, NASA's Juno spacecraft picked up strange radio emissions while flying through this dust. Not from the sun. Not from Earth. What's transmitting through a cloud of ancient debris? And in simulation theory, the zodiacal light could be the visual leftover of a rendering boundary. A region in the system that's soft-lit by default, like background fog in a video game. A way to ease the transition from one environment to another. Or maybe it's symbolic. A quiet line in the sky to remind us that not all mysteries are loud. Some whisper. Some glow faintly. Some just hang there waiting to be noticed. So if you ever find yourself under a clear sky, just before dawn, or just after sunset, look low. Look gently. Because the universe might be glowing softly back. Do these theoretical particles quietly reshape our understanding of physics? Take a magnet. Break it in half. You don't get a North Pole and a South Pole. You get two smaller magnets, each with their own north and south. No matter how many times you split it, you'll never isolate a single magnetic charge. North and south always come together. But what if they didn't? What if, somewhere in the universe, there were particles with only one magnetic pole? A magnetic monopole, something with only north or only south. The magnetic equivalent of an electron. A charge with no opposite. Physicists have searched for them for decades. They're predicted by grand unified theories. Models that aim to unite all fundamental forces. In fact, many versions of early universe physics say monopoles should exist. They might even be relics from the Big Bang. Leftovers from when everything was hot, fast, and strange. But here's the mystery. We've never found one. Not a single magnetic monopole. We've built massive detectors. We've searched in deep ice, in cosmic rays, in particle accelerators. Nothing. So either they don't exist. They exist but are unimaginably rare. They exist but we don't know how to look. But if we found even one, it would shatter and complete physics at the same time. It would validate entire theories, unlock new symmetries, and possibly allow for technology we can't even dream of, like manipulating magnetic fields the way we manipulate electricity. Some theories even suggest magnetic monopoles could catalyze proton decay, slowly eating matter itself. Others propose they could be cosmic seeds, tiny anchors of structure in the early universe, around which galaxies formed. And in simulation theory, a magnetic monopole might be the marker of a system-level variable. An object that was never meant to appear inside the simulation but slipped through. A debug artifact. A cosmic placeholder. That rendered anyway. A single particle that doesn't fit. Because it comes from outside the model. So we keep searching. Not because we're sure it's there. But because, if it is, it will change everything we think we know about how the universe works. And if it's not, then we're left with an even bigger mystery. Why did the math tell us to expect it, if it was never real at all? Could a mysterious force push the universe apart faster and faster? Gravity pulls. It binds. Keeps planets in orbit, holds galaxies together, shapes the structure of the universe. But something is pushing back. Something is making the universe expand. Not just steadily but accelerating. This discovery shocked scientists in the late 1990s. Two teams measured distant supernovae and found that they were dimmer than expected. Farther away than they should be. That meant one thing. The universe wasn't just stretching, it was doing it faster and faster over time. So what's causing that acceleration? We call it dark energy. But that's just a name for something we don't understand. It behaves like anti-gravity. A force not of attraction but repulsion. Pushing galaxies away from each other, making space itself expand. It doesn't clump. It doesn't shine. It doesn't interact with matter. Except through this quiet, overwhelming push. And here's the unsettling part. Dark energy makes up about 70% of the entire universe. More than stars, planets, black holes. More than everything we can see or touch. Which means most of the cosmos is made of something we can't explain. Something that is, quite literally, tearing it apart. Why does it exist? Where does it come from? Why no? Some think it's a property of space itself. As the universe grows, more space appears and with it more dark energy. Others believe it's the result of a cosmic field, filling space with a repulsive tension we can't detect directly. Or maybe it's something else entirely. A sign that the laws of physics are incomplete. A hint of extra dimensions. A flaw in the simulation. In digital terms, dark energy might be the expansion protocol. A way for the simulated universe to grow with its observers, keeping scale flexible, generating more world as needed. Or perhaps it's a pressure release. A long, slow burn designed to keep everything from collapsing too soon. Not a glitch, just a very patient system reset. And what does it mean for the future? If the expansion continues unchecked, it could lead to the Big Rip. A scenario where galaxies, stars, planets, even atoms, are pulled apart by this quiet, unstoppable force. No explosion. No warning. Just drifting. Unraveling. Becoming less and less. Until nothing remains but thin, cold space. Not with fire. Not with ice. But with repulsion. The universe could die not in a bang or a freeze. But in a long, slow push. From something we can't see, can't touch, but feel everywhere. Are billions of planets quietly roaming the galaxy, unseen and unknown? We imagine planets as homebodies, tethered to stars, held in orbit. Warmth, light, seasons, gravity's embrace. But not all planets stay home. Some are adrift. Rogue planets. Worlds without stars. Cold, silent. Wandering alone through the dark. These are real. Not theory. Not science fiction. We've detected some, barely, through subtle gravitational lensing. A flicker in the background light of distant stars. Evidence that something massive and invisible passed in front. Some estimates say there could be billions of them in our galaxy alone. Maybe more rogue planets than stars. Planets flung away during violent births. Or worlds that formed in isolation, never tied to a sun. And what are they like? Imagine a gas giant bigger than Jupiter with no sunrise. Or an Earth-like planet ice-locked in eternal night. Beneath the crust? Maybe liquid oceans heated by internal pressure. Maybe life. Maybe cities. Maybe nothing at all. The scariest part? They're impossible to see. No light. No reflection. They don't glow. They drift through the dark like ghosts. One could be passing through the outer solar system right now. We wouldn't know. Not until it tugged something, tilted an orbit, disturbed a comet, darkened a distant star just enough for us to blink. And then there's the question no one wants to ask. Could a rogue planet ever wander too close? What would happen if a starless giant passed near Earth's orbit? Would it throw us off balance? Would it steal the moon? Would it drag us into the void? Or maybe it's already happened. Maybe a rogue planet brushed by in Earth's deep past. Maybe it seeded life. Or reshaped history. And then slipped away undetected into the black. In simulation theory, rogue planets feel like forgotten variables. Objects generated without anchors. Unassigned nodes. Floating architecture never meant to be part of the story but still there, lurking in the background code. So when you look up into the night sky, and you count the stars, remember, there are far more worlds you'll never see. Hidden. Wandering forever in the dark between lights. Why does the universe softly hum with a mysterious, unexplained sound? You'd think space would be quiet. No air. No wind. No atmosphere. Just the silent drift of stars and time. But in 2006, scientists turned on a radio detector aboard a high-altitude balloon. And they heard something. A roar. Not from Earth. Not from the sun. Not from anything we could explain. It was 6 times louder than the expected background noise. A constant, powerful radio signal, coming from every direction. Not static. Not interference. But something else. They called it the space roar. And to this day we don't know what causes it. Could it be ancient galaxies too faint to see? Could it be from the early universe? Echoes of cosmic dawn? Maybe. But the numbers don't add up. Even accounting for every known source of radio waves, the roar is still too loud. So, what is it? A million tiny sources we can't resolve? Or one vast source we don't yet understand? Some suggest dark matter interactions or the decay of exotic particles. Others wonder if it's the combined whisper of black holes, emitting radio waves as they spin. And then there's the weirder possibility. What if the roar isn't random at all? What if it's a signal? A cosmic hum, not noise but code. Something intelligible, if we only knew how to listen. Or maybe it's not from this universe at all. Maybe the roar is leakage. A bleed through from parallel dimensions or from something outside the observable universe. The static of realities bumping up against ours. And in simulation theory, the roar could be the background process. The low-level hum of a massive computation running beneath reality. Not a bug, but the sound of the system itself. A soft, persistent reminder that what we experience as silence isn't really silent. So now, when we point radio telescopes at the sky, we hear it. Every time. A constant tone. A cosmic breath. They're in the background. Always there. The universe is humming. And we still don't know why. Let's listen to the end. Will the universe gently fade away, or be torn apart at its seams? We're here now, in the golden age of stars, structure, and life. But the universe is still expanding, growing colder, darker, and lonelier by the second. So the question becomes, how does it end? There are a few possibilities, each one more unsettling than the last. The big freeze. If dark energy continues to push galaxies apart, then over trillions of years, stars will burn out, black holes will evaporate, and the universe will drift toward absolute zero. No light, no warmth, just cold particles scattered in a silent void. This is heat death, maximum entropy. Everything still, everything forgotten. A soft ending stretched across eternity. The big rip. But what if dark energy isn't constant? What if it gets stronger? Then not just galaxies, but solar systems, planets, even atoms, will be ripped apart. First the galaxies unglue. Then stars pull away from their planets. Then molecules split. Then the very fabric of space tears. The universe doesn't freeze. It shreds. Everything pulled apart by an unstoppable accelerating force. The big bounce. Or maybe expansion will reverse. Gravity takes over. Galaxies slow, stop, and then fall back in. The universe contracts. Gets hotter, denser. Until it collapses into itself in a fiery implosion. Maybe it starts over. A new Big Bang. A new universe. Again and again forever. The eternal now. Some theories suggest time isn't even real in the way we think. That the universe is one static block. Past, present, and future all existing at once. No beginning. No end. We just experience it as a flow. The end? It's already out there. Frozen in a part of the timeline we haven't reached. And in simulation theory, the end could be simpler. A server shut down. A choice to stop rendering. An experiment completed. Or a reboot. One moment you're here. And the next, nothing. Whatever fate awaits us, freeze, rip, bounce, or vanish, it's a reminder. The universe is not static. It's a story with an ending. And you're alive in one of its middle pages, reading quietly, while the last chapters write themselves beyond the stars.